Thank you for joining this lesson. We are going to handle uniform circular motion. So we will see a calculation here whereby we are told that a stone of mass 0.2 kilogram is attached on an inextensible string and whirled in a vertical circle of diameter 1.0 meters at a constant speed of 7 meters per second. Determine the part 1 angular velocity of the stone. So we can start with part 1, determining the angular velocity. So we know that linear velocity, first of all, when a body is in a circular motion, is given by r omega, whereby r is the radius and omega is the angular velocity. So this means for us to get the angular velocity, then we will need v divided by r, and the v is the linear velocity of 7. So we divide with the radius. We are given the diameter for this circular path, therefore we should follow the radius, which will be 1 divided by 2, because the diameter is 1 meter. Then we divide it by 2 for us to get radius. Therefore this will give us 14 radians per second, because angular velocity is given in radians per second. So that is how part 1 is done. Part 2, the centripetal acceleration of the stone. So centripetal acceleration is usually given by v squared out of r. So the linear velocity, which is 7, when we square it and we divide with r, we can check the answer. 7 squared, then we divide by r. This gives us 98 meters per second squared. So this will be 98 meters per second. Okay, alternatively, this part 2, we can say that because velocity is given by r omega, instead of v, we can have r omega, such that when we have r omega and we square them, r omega squared, then divided by r. So we are having a r omega instead of v, this equation, and you realize that acceleration centripetal can be calculated by r squared divided by r. We get 1r, then omega remains squared. Therefore we can have r 0.5 and omega, which has been calculated as 14, we have it squared, and you will find for sure the same value is obtained when we follow this other formula. So we can still follow this formula. We can get to Roman 3. We are told to determine what? The least tension in the string. So the least tension is when the stone is at the topmost part of the circular path. When the stone is here, you realize that when it is at the top part here, you realize the weight of the stone and the centripetal force are both acting downwards. Therefore you find the resultant force is given by, so we're saying both tension and the weight are acting downwards, and you find centripetal force is given by both the weight of this stone and the tension, such that to get tension we have to subtract the weight from centripetal force, which is given by mv squared out of r. We subtract mg. So the minimum tension is found at the top, whereby we get the difference of centripetal force and weight of the stone or whichever object it is. Therefore the tension is minimum when we take a mass of 0.2 kilograms as given in the question times v squared out of r 0.5. Then we subtract 0.2 by 10 gravity due to earth. So this is going to give us 0.2 multiply with 49 and we divide with 0.5. This gives us 19.6 minus this one becomes 2. So we realize here we are getting 17.6 Newton as the minimum tension. And finally we are getting maximum tension. So maximum tension is when the stone is at the lowest part. At the lowest part we have both the weight is acting downwards, but tension on the string, since it is held here, the tension is acting on the other side, such that centripetal force is given by the difference between the tension and the weight of this stone, which means to remain with the tension, then we have to bring the weight on this side and have centripetal force plus the weight of the object. Therefore, tension maximum is going to be gotten by mv squared over r, which has already been calculated as 19.6, but now we add 2, and this is going to take us to 21.6 Newton. This one is the maximum tension which is acting on the string. Thank you for following. Subscribe to this channel and share the link with your friends.